Now see here, this is next one is a compound microscope. This is another optical instrument which is actually used to see here for a small object or very tiny object. Basically it is used in biology. Now suppose object AB is here in front of the objective lens. So this lens is known as here objective lens, has got a smaller focal length. This one is known as eyepiece, or you can say eye lens. This has got the longer focal length and large aperture as compared to this one. Now, two rays coming from the object AB, where a small object is placed beyond the focus of the objective. After refraction meeting at this point, and image of that object is obtained A dash B dash at this point. Then this image acts as an object for this lens, eyepiece, and this object or this image is actually lying between the optical center and focus of the eyepiece. So obviously the virtual image and highly magnified image will be obtained, as we have seen in the simple microscope. Now final image of this object A dash B dash is obtained, A double dash and B double dash, which is at the least distance of distinct vision from the eyepiece, that is a capital D here. Now see, angle subtended at the eye by this final image is beta, and when we compare, when we place the object at the same distance, the angle subtended at the eye is here, that is alpha. As we have already defined magnifying power, m is equal to, that is beta upon alpha. This can be also written for a small angle, that is here tan beta upon tan alpha. For a small angle I am talking about. So this is here the magnifying power. Now we will calculate it here. Tan beta we can write here, m is equal to A double dash B double dash divided by C2B double dash into tan alpha I am taking in the triangle PB double dash C2. So that can be written here PB double dash upon C2B double dash. These two can be cancelled here. Now we can write A double dash B double dash divided by PB double dash. So now we can write PB double dash is equal to AB. So this one will become here, now I am writing this formula is here. So we can write m is equal to A double dash B double dash upon AB. Now this we can multiply and divide by A dash B dash, this one, this image. So we can write A double dash B double dash upon A dash B dash into A dash B dash upon A double dash, see here, that is AB. This is magnifying here, power of the magnification is here for the eyepiece. So that is written ME into M into O. And for this ME, when the final image is obtained at the least distance of distinct vision, already we have calculated magnifying power. So by the same method which we have used in case of the simple microscope, that is by using lens formula, we can calculate ME is equal to 1 plus D upon FE. FE is here the focal length of this eyepiece. And we can also calculate here MO is equal to, we can write here V naught, that is from here to here the distance, image distance for the objective, V naught upon minus U naught. So this we can write. So now the total magnifying power can be written, m is equal to, by multiplying these two, we can write m is equal to V naught upon minus U naught into 1 plus D upon Fe. And here this negative sign here shows that the final image is inverted one. So we have got this formula. Suppose we take U naught is approximately equal to F naught and V naught is approximately equal to L, that is the distance between these two C1 and C2, that means the distance between two lenses. Then the same formula can be written here, m is equal to L upon minus F naught into 1 plus D upon Fe. And if the final image is obtained at infinity, then we can write the same formula, magnitude of the magnification can be written, m is equal to L into d upon FO into FE if the final image is obtained at infinity. So, I have used here the steps which we did already in the simple microscope. You can also derive by the same way and get the magnifying power for the compound microscope in different cases. Now, see astronomical telescope, that is actually a refracting type telescope. See here, astronomical telescope is an optical instrument which is used to see heavenly bodies like stars, planets, etc. Now, see here, there is first objective lens which has got large aperture and larger focal length because it has to gather more light. So, if the object is at infinity, the rays I have taken, these are the parallel rays which are coming from the object which is at infinite. When these rays fall on this lens, objective lens, they gets converged at this point. This is the focal point of the objective lens, that is represented by f naught. So, the real and inverted image of the object which is lying at infinity is formed at this point. Now, another lens, that is the eye lens or the eyepiece, this is adjusted in such a way that this image is at the focus of this lens. So, that is why I have taken here this is Fe. Now, these rays fall on this eyepiece lens, this eyepiece lens refract these rays and finally, the image is formed at infinite. So, the final image is also at infinity. So, see here, this type of the telescope is used to see heavenly bodies. Object and image both are at the infinity here, and also this situation of the lens is known as normal adjustment. This situation of telescope is known as normal adjustment. Now, we can define magnifying power of the astronomical telescope. See here, magnifying power m is equal to beta upon alpha. Beta is the angle subtended by the image at the eye which is at infinity actually, and alpha is the angle subtended by the object which is at also infinity. So, the magnifying power of a telescope is defined as the ratio of the angle subtended at the eye by the image and the angle subtended by the object at the eye when both are at infinite distance. So, we can write m is equal to beta upon alpha. For a small angle, we can write here that is tan beta upon tan alpha. So, m is equal to tan beta upon tan alpha. Now, we can write tan beta. So, m is equal to tan beta can be written a dash b dash upon c2 b dash. So, a dash b dash upon c2 b dash into tan alpha can be written here a dash b dash upon c1 b dash. This and this will get cancelled. Now, I will be getting only here c1 b dash upon c2 b dash. Now, see here you can write m is equal to c1 b dash. C1 b dash is the focal length for the objective and c2 b dash is the focal length for the eyepiece. So, this one is a positive, this we take as a negative. So, we can write here m is equal to FO upon minus FE. So, this one is known as actually the magnifying power of astronomical telescope, which is actually here coming negative. Negative sign is indicating here the final image is inverted with respect to the object. So, we can also get magnifying power of the telescope in case the final image is formed at the least distance of distinct vision, and that is at the 25 centimeter, and also here this already we have done. But this is a refracting type telescope. Now, we will study about the reflecting type telescope.